The FDP Institute provides world-class training and education to financial professionals to meet the accelerating needs of digital transformation in the industry. The Financial Data Professional Institute was established by CAIA Association to address the growing need in finance for a workforce that has the skills to perform in a digitized world, where an increasing number of decisions will be data and analytic driven. The FDP credential is the first of its kind in the industry and reflects expertise in data science and its practical applications in finance. To earn the FDP designation, candidates have to complete a selection of either Python or R classes. These can be completed either before or after the exam. The comprehensive exam contains 80 multiple choice questions and 2 to 3 constructed response questions. There are no programming questions on the FDP exam. Similar to the CAIA and CFA exams, the FDP exam is built around 9 topics that are reflected here on the screen. The study guide provides a roadmap to target your study hours. And just like the CAIA exam, we offer 2 test options for our exam, either in a test center or through remote proctoring. Registration for the October exam will open on May 25th with early exam enrollment. With that, I'd like to welcome you to today's webinar. At this time, I'd like to turn it over to Keith Black, Managing Director, Program Director, and also an FDP charter holder. Welcome, Keith.
Thanks, Kim, and welcome everyone. We're excited to be here today to share with you about AI and machine learning. So today's guest is Sri Krishnamurthy from Quant University. And so Sri, we're excited you're here with us today to share some stories about AI and machine learning in the financial market. So Sri has some prepared remarks, and at the end of the presentation, we'll have time for some Q&A. So if any questions come up along the way, type them in the Q&A box, and we'll get to them towards the end of the hour. So Sri, thanks for being with us today, and we're excited to hear your story.
Thank you so much, Keith, and thank you everyone for joining in today. My name is Sri Krishnamurthy, and I'm the founder and CEO of Quant University. And just for people who are new, I've been working in the quantitative finance world for more than 20 years. I started my tour of duty in the financial services world at Citigroup after graduate studies in computer science and machine learning. And at that point in time, machine learning was primarily restricted to textbooks and research papers. And if you had to do anything, you had to imagine what the world would look like if machine learning and AI was possible. So fast forward 20 plus years, we are now seeing AI and machine learning kind of revolutionizing the way the financial industry works. And the way data is being processed, alternative data is being used, the advances in natural language processing, all the innovations which are happening with respect to geospatial data and leveraging, purchase information and behaviors with respect to sentiments on Twitter and other social media channels. It's just changing the way the financial industry works. And what we have done at Quant University is basically trying to pragmatize all these concepts which are predominantly in theoretical and research papers and making it accessible to the financial community. I also have a teaching position at Northeastern University where I teach my students big data and machine learning. I've been teaching there for the past 8 years. And it's kind of interesting to see how the field has evolved over the last decade or so with advances in machine learning and AI. So thanks again, Keith and the FDP Institute for prioritizing, what it means to basically bring in pragmatic aspects of applications of data science and machine learning into the financial services world, because it's extremely important for the quants and the data scientists in the 21st century to understand the power of all the technologies which are out there. So what I'm going to do in the next 30 to 40 minutes or so is just give you a quick overview on kind of the key trends which are happening in AI and machine learning in finance. So this is going to be an introductory session. I'm not going to be sharing any equations, and I'm not going to bore you with code. So I want to excite you on the possibilities with AI and machine learning. And I'm going to illustrate one case study which I teach my students on how to pragmatically apply techniques in natural language processing for processing Edgar filings so that you can get a feel for the kinds of things you could potentially do. And we will end today's session on the kinds of things you need to think about learning as you take your journey towards applying AI and machine learning in the financial services world. So that's kind of the plan for today. And if you have any questions, please feel free to type it in the chat window, and I'll be happy to answer them as we kind of end the session today. So for people who are kind of understanding why we are talking about AI and machine learning, we just want to contextualize how the world has progressed with respect to technology. In the last 100 years or so, we have seen multiple industrial revolutions. When we thought about how do we define the power of let's say a pump or a car, we talk in terms of horsepower, because in the past we used horses to basically designate how many horses do we need to do certain things, right? So with automation, we started realizing that machines can be better and faster at certain things, and we want to be able to leverage the power of machines. We started optimizing it by saying, well, instead of we doing one car at a time, if we basically build out pipelines so that we can assemble multiple cars at a time, we could gain efficiencies, we could gain scale. And we started building those kinds of technologies. And then we started realizing that, well, humans can make errors. So if we started to automate things, if we designate computers to do certain things, we will be able to do things faster, better, cheaper, without much errors. And today we are kind of designing autonomous systems. We are basically transferring some amount of intelligence to machines. We are leveraging data from multiple sources, and we're trying to understand and contextualize information so that we could basically build out ecosystems and design systems which not only focus on the data at hand, but also can make predictions, can understand what's actually happening, and react to the changing scenarios in the market. So this is where we are. We are kind of talking about the fourth industrial revolution. And what that means is the future is going to change like anything in the next 30 to 40 years. We have been talking about Uber. Who knows? Maybe in the next 20 to 30 years, we're going to have flying machines, and we're up for a revolution which we have never imagined, and we have only probably seen in sci-fi movies till now. Now, we need to kind of contextualize why we are talking about machine learning and AI and why these are becoming pragmatic things in the industrial world. So this is a graph which is a couple of years old, but I just want to kind of give you a feel for the amount of research which is happening in various areas. On the left graph, you see this green line talking about scientific publications in machine learning. And you can see that, this is sometime during my graduate studies, 97, 98 timeframe. Very few, there was kind of a linear growth, not much was happening. But you see this significant increase in the number of scientific publications, which has happened in the last 20 years or so. The more interesting part for me is looking at the patent filings, which means that companies are realizing that it's not only the research which is helping them, it's the practical applications and the competitive advantage which they're able to gain because of machine learning. And they're filing patents, and you see a significant increase in patent filings in the last 5 to 10 years or so. And if you kind of just drill down a bit, you're going to see things like neural networks, support vector machines, rule-based learning, deep learning, having similar trends. You see the number of scientific publications, patent filings, especially deep learning, which is a form of machine learning, which I'll briefly introduce you to a little bit. So you see the significant amount of interest, both in the scientific literature, but also in patent filings. So what that means is, the industry today is seeking to gain this competitive advantage by applying AI and machine learning. And this is, evident in, when you look at bank hiring, BlackRock, JP Morgan, Goldman Sachs, they're all interested in hiring talent, wanting AI and machine learning skills. Now, I want to give you an example on why it becomes important for us to understand the nature of where, the kind of things which are happening and why you need to be interested in applying these kinds of techniques. So we'll kind of go a little bit further. We'll not stick around at the Twitter saga, which is happening with Elon Musk. We'll just go back to the Tesla saga, which happened in the 2018 timeframe. Notice the time stamped in here. It was 9:48 a.m. on 7th August 2018. Elon Musk sends out a tweet saying, "I'm considering taking Tesla private at $420. Now, this was sent over Twitter. No news conferences or announcements were made. But on the Bloomberg terminal, within half a second, this information was available to all the professional traders in the world. And if you look at the graph, the price impact had already happened within a few hours, within a few minutes. So what that means is it's impossible for humans to keep track of all these information sources and take decisions. Most of these decisions were machine-driven decisions. And it's impossible to track, when these news events are going to happen and how should you behave. So it has to be pre-programmed in your systems to make sure that you are able to capitalize on the nature of the information flow today. So it means that, we have to kind of factor in the decision-making systems. And, if you're new to machine learning and AI, predominantly machine learning is leveraging statistical and different kinds of algorithms to understand what has actually happened in the past and relying on patterns and inference to basically make decisions. But artificial intelligence is much more than that. It's basically kind of replicating intelligence displayed by humans and animals. And what we do is we basically say, okay, we can leverage historical information, but we will also be able to use rules. We'll be able to use other methodologies to learn how to behave in certain scenarios. Now, what's driving this, important phenomenon? And I kind of categorize it into three segments. One, the data. Today, we are seeing significant amount of data being generated. If you look at the ways in which we are collecting data in terms of volume, this amount of data was not even possible to be stored in systems even just a few years ago. But we're generating so much data and we're collecting all these pieces of information. If you go to a website, there's so much information which is being generated and stored as you kind of browse through websites. It's tracking how many clicks you're making, what pages are you looking at, how much time did you actually spend on a page, what part of the website are you currently focused on. There's so much information which is being generated as we speak. In addition to that, the velocity, which is the amount of information which is coming through. Because of sensors, because of social media, we are more or less getting real-time feeds of events happening like the Tesla example I just gave you. And the variety of data. So a lot of discussion is happening with the inflation story and with the supply chain shocks. There are a lot of companies which are tracking alternative data sets, like what's happening with cargo metrics, how many ships are actually coming in with inventory, how many ships are actually leaving ports, where is the bottleneck, and all these are being tracked in real time. And geospatial information, audio information, image information, all these are being collected and tracked. And in addition to that, social media is becoming an important part of the news chain through which information is being dispersed. And with all that comes the veracity aspect of it, which means that how do you trust that with all this information coming through, which information is real, and how do you process that information, and how do you make sure that you're taking the right kinds of decisions based on the information sources you trust. So data is one piece of the puzzle. But in addition to that, you had to think about the amazing evolution of the software ecosystem, which has happened over the last 10 years. In the first, if you look at 15 to 20 years ago, most software ecosystems were kind of held, the keys were held by large software companies. You had the Microsofts and the Oracles of the worlds who were basically creating enterprise software systems, and you had no go. You had to just go to these companies and leverage their ecosystems to build out your software stacks. In the last 10 years, we have seen a significant change in the way software is being developed. and it's the ecosystem of open source. Most of the machine learning libraries, most of the ecosystems which are being developed currently has been developed in the open source realm. And it means that the access and the bar has come down significantly, and anybody can go and download the latest machine learning algorithm and try it on their machines, which means that you have a lot of competition. These software systems are accessible by a small startup to a really large enterprise, and all of them have more or less the same amount of technology. And it means that the companies which are investing in kind of building out the smart algorithms are going to win. In addition to that, you're seeing a lot of systems which are factoring in the pragmatic changes of the way the world has worked, which means that you are no longer investing in static hardware. In 15, 20 years ago, companies would say, I'm going to buy a machine, I'm going to buy a server, I'm going to put everything in together and then connect them and then try and build algorithms. But today, with a simple laptop, you can connect to the cloud, rent any amount of hardware you want, and run your calculations in the cloud, which means that you don't have to think about significant amount of investments to try out new technologies. And if you find that there is an advantage of using a particular technology and scaling it up, you should be able to just kind of scale your algorithms with the cloud without having to do much work, which again, reduces the bar of what you can potentially do. And you don't have to worry whether you're a small company or a large company. You more or less all have the same access to the cloud, and you can actually work with that. And in addition to that, there have been a lot of innovations in the hardware space, wherein you can use things like GPUs, FPGAs, and quantum computing is also coming as we speak to enable you to do calculations at a very fast pace. So with all these changes, what has happened is, this area of fintech is becoming more and more prevalent, and it's challenging the traditional financial industry with innovative business models and with emerging technologies. And we're seeing a lot of new things coming up, especially in the payment space. We're seeing, small companies kind of, challenging the way payments are actually done. You have the Stripes of the world, the Squares of the world, basically challenging how traditional, ecosystems like MasterCard and Visa were treating payments. You all heard of, the DeFi, blockchain, crypto revolution, and now we are talking about, alternative currencies. And today, I think Fidelity made an announcement that you could potentially add Bitcoin to your portfolios. So there's a lot of discussion happening on what does it mean to look at traditional investments and look at some of these volatile currencies, and what does it mean to think about a portfolio wherein you are including Bitcoin and other kinds of technologies. But in addition to that, what's the role of smart contracts? How do you treat contracts? How do you transfer money? What kind of assets do you typically hold? Is it going to be just physical assets or digital assets with all the things happening in the NFT space? So there's a lot of new innovations happening in that space. In addition to that, you've all heard of the robo advisors and the Robinhood phenomenon, if you will. There is a lot of discussion on what does costs mean in terms of transactions. How do you typically encourage people to trade? How do you think about portfolio management? How do you think about tracking these ecosystems? So there's been a lot of discussion in the trading and investment space by applying various technologies. And then financial planning tools. There's a lot of discussion on how do you think about education planning, retirement planning, and how do you tap into different demographics. So a lot of AI and machine learning models are being used to look for who should be the marketing models on who should be targeted and how could you potentially build products for specific demographics. And it's not just kind of having one product and making that product available to all. It's about customization. It's about personalization. It's about understanding the dynamics of particular demographics and their requirements, and then building products appropriately for those particular demographics. And then obviously lending. There's been a lot of discussion on, well, should we just focus on traditional scores like the FICO scores? Should we look at other kinds of behaviors person exhibits, when did the last transaction of a particular kind happen, and what aspects could be factored in when you're making credit decisions. How do you handle risks when someone doesn't have credit history? So there's a lot of discussion on using AI and machine learning in the lending space. And insurance, which, as you know, most of the insurance products, it kind of lags behind the technology evolution. Most of the technologies were traditional, but that's going through a lot of innovation in the context of InsurTech, with a lot of discussion happening on how do you create products which are contextual, which may be time-based, which are requirement-based, and you're seeing a lot of new companies creating innovative insurance products. Now, what has happened is the AI and machine learning revolution has brought about so many innovative technologies that we're just scratching the surface. There is a lot of discussion on what kinds of new financial products are going to come in. How will they challenge the existing ecosystems? How will the corporates innovate? Because they have a lot of historical data they have stored and they've collected over time. So will they be creating new products? So this whole revolution is just starting, and it makes sense for us to understand these technologies and make sure that you can kind of align your strategies to leverage these opportunities which are out there. Okay, just a few examples in here. You are already familiar with AI and machine learning, and you're using it on a regular basis. I mean, in the morning when I wake up, I always first ask about the weather. I use Siri or Alexa or Google now to basically interact and get information from what's actually happening. There are also new automation methodologies which leverage machine learning. So if you've used some of the speech-to-text tools, or if you're making certain transactions, or if you're asking information about your accounts, your chatbots and virtual financial assistants, they're all automating certain things which are happening for you, and they're all leveraging machine learning techniques. But there is also, on the investment side, a lot of diverse data sets are being used for investment decision making. A lot of traditional quantitative investing is now leveraging data science and machine learning techniques, especially when you're adding more factors. It's not only the traditional factors we are familiar with in our traditional quant investing. We are now looking at alternative data sets, like what other factors could be added towards our investments. And also companies are building sandboxes to figure out, well, what if we invest in a particular area? How will we be able to create new and innovative products? And they're also figuring out how can we build out various aspects for automating and then increasing the user experience as we build out various examples. So that's kind of the big picture. I want to kind of briefly tell you about what typically happens under the hood when you build out machine learning. And some of you who have built out machine learning models probably are already familiar with some of these concepts. So apologies if it's too rudimentary. But I just want to kind of set the stage for what machine learning and AI development is all about, because it's not just building the model. Because many times people think that I'm just going to learn a Jupyter notebook and just build a model and think that, okay, I'm done with my model and I'm good with it. But in order to leverage the entire ecosystem, there's a lot of opportunities and a lot of key pieces to the puzzle which needs to come together. And so in this cycle, what you're seeing is a typical workflow. And what actually happens is, companies would say, what, I'm going to be using certain kinds of data sets. Maybe I'm going to scrape data from websites, or I'm going to connect to various APIs and get the data in. And then I'm going to try and understand what kind of data I'm working with, understand the distributions of my input data, and the modeler would choose what data sets to use to build out the models. There's a lot of data cleansing involved because most of the machine learning models are data-driven models. If you don't have high quality data, the machine learning models are not going to be that good. So in order to make sure that you get the best possible outcomes from your machine learning models, there's a lot of processing that needs to happen. And then there is this notion of feature engineering, which is to understand what features are driving these outcomes and how do we make sure that we get the best features And do we need to do some additional feature engineering so that we kind of focus on the features which are going to, get the outcomes in the right way? And then the modeling phase comes in. This is, a lot of emphasis is typically put in this particular phase, because here's where you have the options to go with traditional modeling, like regression and similar frameworks like logistic regression, et cetera. But you can also go towards other kinds of models like neural networks or random forests or decision trees, or even simpler techniques which could potentially be used like KNN. So there's a lot of choices in here, which means that you have to intelligently decide for the application you have at hand what needs to be done so that you can factor in all these aspects. And then comes the tuning and evaluation to understand, like, what am I actually trying to focus on? Am I focusing on accuracy? Am I focusing on the error rates? How do I optimize my model to get the best possible outcome? And then you basically think about like selecting a model and you deploy it. And that's where you're going to think about, well, I'm going to be able to do these kinds of transactions. And for this is the data I'm going to get in. And then how do I actually process these outcomes? Do I process the outcomes automatically? Do I have a human in the loop? If something doesn't go as per plan, what is that kill switch so that I can make sure that I'm not going to let the machines take all the decisions? All those kind of go into the space wherein you're going to design systems to make sure that you're responsibly deploying your machine learning models. So there's an entire process, as you can see. And the analogy here is the first slide I showed you, wherein when Ford was designing these pipelines for processing these cars and automating these cars, it went through engineering. And there's a lot of engineering which happens to make sure that you leverage the most of building of your particular models. So with that said, Keith, I can pause here for a second if there are any questions, or we can continue going.
I don't see any questions yet, but what's interesting to me is how broad these applications are, because somebody might think that we're only going to use these techniques for stock picking, but you see this used in credit card applications. You see it used in mortgages. You see it used in insurance, and it's not just numerical data, right? It's textual data as well. And I think you're going to get into a little bit of the applications of natural language processing here in a few minutes. But
absolutely,
it's interesting how broad the applications are.
Yeah, and that's kind of the power of machine learning, right? Because you have the ability to bring in disparate kinds of information. And you have models, the research has evolved significantly over the last 15 to 20 years, that you have models and applications on various spaces. So it's not just about stock picking. It's not about just, thinking about it's going to be transaction oriented. There are so many pieces in the financial ecosystem which leverages data. And wherever you see there is some amount of friction, it provides an opportunity to innovate and bring about products which could potentially make things easier, simpler, cheaper, faster.
And one thing that I've noticed in my FDP studies is that it's not the coding that's the hard part. It's understanding the business requirement and getting and cleaning the data, because we've built these Python open source programs, and you could build a machine learning model in Python in 8 lines of code. And you simply say model equals random forest, right? And somebody out there for free has written hundreds of lines of Python code that we could all use, that we could just call using a routine called random forest. And so it's not necessarily the coding that's the difficult part. You really have to understand the data and what you're trying to get out of the model.
Yeah, and again, there is, I tell my students when they complain, when they come to our programs at Northeastern, like, why should I be learning how to do bubble sort? Why should I be learning how to write a search, algorithm, right? And that's, there is the understanding aspect of it, like what goes under the hood, but there is also the application part of it. So the Python libraries have made the application part easy, by providing you interfaces which are simple enough. But the cautionary note is, and I'll try to get to a little bit in here, you got to understand. I mean, like, just because you have a simple interface doesn't mean that you can apply it, because I think in the financial industry, if something bad happens in the engineering world, it'll tell you that this is not right because you have really good ground truth, right? So, if I basically design a mechanism wherein I say, okay, so this is going to track certain things, and I'm going to go and, design something which is going to hit a particular target. So that one, when I test it, if it doesn't work, I know it doesn't work because I have the ground truth. Unfortunately, in the financial industry, we don't have really good ground truth. Things are constantly changing. And in addition to that, we don't just keep using our money to trade, or we don't just keep investing our own money. We have a fiduciary responsibility, which means that we want to make sure that we test it, we validate it. And most of the times in my Citigroup days, I was spending a lot of time doing the due diligence. So what that means is, the libraries will give you the power to adopt technologies very easily, but you still need to go through the rigor of understanding what's actually happening, right? So that's kind of a good transition to just basically, get to know some of the things you need to understand. And that's why the formality is required. And I mean, like, you went through the whole FTP program yourselves, Keith. So you understand, like, you read through so many papers, and there's been a lot of rigor and there's been a lot of science, which is, it's things you need to know, because if something doesn't go as per plan, you need to be able to go and investigate what actually happened, right?
Now, Sri, what do you think of the idea that if you understand the data and you understand the methods, that you don't have to code at all? What do you think of like a no-code solution, like a data robot?
Yeah, I would kind of, again, I'm kind of coming from the practical aspects of what would you do in an industry, right? So in the industry, there are multiple things you could do, especially if you're trying to do a benchmark, saying, you know what, I'm putting in all this effort to build a model. How good am I building my model, right? So if I want to test that out and I don't have a good benchmark, I could potentially say, okay, let me see automatically if a machine learning algorithm can try out multiple things and come up with a solution. And that's what typically a data robot like a solution or any automatic machine learning solution would provide you, with the ability to kind of, say, hey, you don't have to spend a lot of time doing hyperparameter tuning, choosing different algorithms. We will do it for you. But you need to have the mechanism to understand, is that good enough? If something bad happens, what's going to be the cost of it? What's the risk associated with a bad decision? And if a marketing model goes wrong and I'm not able to target something appropriately, if I'm saying I'm going to run a marketing campaign to issue credit cards to 1,000 people, and my marketing model gave me, here are the 1,000 people you should target, and I was expecting 5%, acceptance rate, but it was only 3%. And say, oh, the model is not that good enough, right? But if I'm building a solution which is going to be trading a lot or having very critical decisions, then I'm going to be responsible for my models, and I'm not going to be typically going for a low-code, no-code solution. I will need those PhD data scientists to tell me that this is going to work, and I'll battle test it before I deploy it. So it all depends on the context and the use case. So it's easier. Easy doesn't mean, if it's easier for everybody, for every use case, we would not be doing any more research. We would say the problem is solved. We'll just go for, like a point and click solution. But I think the problems are diverse, and, the risk spectrum is big enough that you need to be able to intelligently apply the right solution for the right job.
Thanks, Sri. I'll let you get back to your prepared remarks.
Yeah. So this is one example, just to kind of connect the dots. If I'm going to be doing fraud detection, there is a cost involved. Like if I'm letting a lot of frauds going through my algorithms, then obviously I'm going to be losing money as a bank. But if I put in like very tight rules, then everybody's going to get blockages for their credit card usage, and they'll say, no, I don't want to use this credit card just because I'm getting so many alerts and my transactions being blocked. So there, it's what's called as an imbalance class problem. So you got to make sure that your metrics are designed right. So the point is, like, it's not a generic solution for all problems. So similar to a tool being a generic solution for all problems, you got to choose the right algorithm for the right kind of a problem. And secondly, a prototype model is not a production model because it works in a Jupyter Notebook setting, or it kind of worked in a test setting. Doesn't mean that it's going to work in the real world, because in the real world, things keep changing. And you have to think about, like, fitting. Is it just memorizing what has happened in the past? Is it diverse enough in terms of testing that we actually know what's actually happening? And some of the comments in here, I think when we share the slides, you should be able to go through it. But a lot of people in the industry have said, like, well, when we look at these demos, they work fascinatingly with test data sets. Kaggle, people go to Kaggle and download data and say, oh, it works. I know how to build models now. But when you put it in the real data with real models, they don't work. So you need to be able to understand what's driving the behavior of these models. And then this is actually very important and kind of goes back to what Keith was saying. Sometimes we say, oh, it works, but we don't know how, because we don't know much about what's actually happening under the hood. Some of these things need to be thought apart. Like, what does transparency mean? What does interpretability means? What does security means? What does fairness means? Because many of these algorithms cannot be using PIIs or private information. And there's a lot of legislation, fair lending laws, et cetera, et cetera. So you should be aware of some of these aspects. And then the metrics, the algorithms will say, if you say optimize on accuracy or optimize on error rates, it'll do it, but it does not have the context on why it should be doing that. So that's where humans come in. So you should be choosing the right metrics for the right job to ensure that you're applying the right algorithms for the right kinds of purposes. And then there's also the hype, right? So, people will claim that, these algorithms work. We cannot tell you more about the algorithms. That's our secret sauce, but it actually works, and I can show you some data. We in the financial industry need to be very, very cautious about claims. Just because there's hype, we should not be going into it, because we have the fiduciary responsibility, and we want to make sure that we understand and we have done the due diligence to ensure that we are applying the right kinds of technologies for the right job. And again, we're just getting started. And as I mentioned when I showed you these graphs, many of these innovations are 5 to 10 to 15 years old. So we don't know everything about what's actually happening. And that's why you got to kind of look at it holistically. What's the alternative? What are the traditional ways of building models? And does it even match what we have already been doing? Okay, I know we are very close. I'm just going to show a quick demo just so that you can get a feel for the kinds of things what people do. So this is a sandbox we have put together, just to illustrate various concepts in many of the courses we do at Quant University. So I'll show you one of the case studies I built to illustrate natural language processing. So many of our programs are predominantly to give you like the facets of the kinds of things which are required when you look at building out these kinds of solutions in the industry. And this is something we have talked to multiple companies, multiple industries on the kinds of things we do, and model risk management is extremely important. Anytime you build a machine learning model in the financial industry, it has to come under the purview of model risk management. And typically the kinds of things you need to understand there is explainability, fairness, security testing, scenario testing, stress testing, different kinds of threat reviews, failure modes, and doing algorithmic assessments to understand how to audit a machine learning model before it's deployed into production. So we kind of look at like a holistic perspective of all these things. And this particular case study, the way we have structured it, so just to give you a little bit of an idea, what we have done is we have looked at these earning calls. And if you look at earning calls, typically there are statements which are made by analysts, and they are trying to kind of provide you context on what actually happened that particular quarter. Not a lot of emotions, and there's a labeling problem because each one of these statements need to be labeled appropriately by a subject matter expert. But many times, there's a lot of solutions which leverage natural language processing to build sentiment and summarization and various techniques. And in this particular case today, I'll just show you how sentiment analysis works. Language is very hard because there are so many kinds of problems which could be addressed with respect to natural language processing. And a lot of companies are now leveraging natural language processing techniques. And I showed you an example of Bank of America. They have a chatbot for understanding what people are saying, to process them and then turn them into actions. JP Morgan, put out something which said, like, they were processing a lot of documents, which was taking lawyers hundreds of thousands of hours, and they were able to reduce it significantly. So there are a lot of interesting applications in natural language processing, which you're already familiar with. If you've been using Google now, Siri, Alexa, etc., you're already using natural language processing for various things. So traditionally, it was very difficult to process language, and machine learning is making it much, much simpler. But you still have a problem of context, because if you do not understand what a jaguar is, whether it's a car or whether it's the actual animal, a tank, it could be full of soldiers, a tank could be full of nitrogen, depending on the context of use, they have different connotations. So which means that there's a lot of testing that needs to be done, and large language models are being used, and most of these are developed by companies like Google and Microsoft and Amazon. They've been providing APIs to process a lot of these kinds of applications. And just to illustrate, what we did was we said, okay, fine, there are a lot of companies which are already providing algorithms. So let's do some benchmarking. So we built out like a case study to say, okay, here's like a transcript. And this is just one of the transcripts we pulled, Q2 2020 for a particular company. So this is kind of the data. So what we'll do is we will basically call APIs, and we will call different APIs for Google, Amazon, Azure. There's a language called as BERT, which Google has made available through their model hub, and then TensorFlow models, which are also available. So we basically applied multiple models to kind of check if I just take a statement and give it to these APIs. And here we are not actually writing much code. We are just leveraging these APIs and saying, you go and tell me, overall, what kind of sentiments are you going to gather for me? So we just did some comparative analysis for various APIs. And you can notice that most of these APIs said, the sentiment is neutral for many of these statements. But then as we drill down, we can kind of see that some of these are positive. For example, TensorFlow said, close to 35% of the statements were positive, but Azure, it said that only around 17% was positive. The same statement, you pass it to two different APIs. One says it's positive, one says it's probably neutral, right? So here you could see that TensorFlow said around 25% of the statements was positive. But then you could see that, Amazon Comprehend said only around 10% of the statements were negative, right? So as you can see, even with commercially available APIs, the same data overall, you have different results. And this was just, we looked at like the most positive statement. So this whole statement was considered as positive, but then Azure considered this as neutral, and TensorFlow said that this statement was negative. And then on the negative statement, you had like, a lot of them saying, so the idea is little influence of the market as possible. I believe there's no other payback required really to meet the supply of shares. Its supply is limited to such low percent at 15%. So that was the first question. So Google said that this was the most negative statement. And similarly, we kind of, looked at a bunch of different statements just to understand, what statements were the most positive statements. And you could see the discrepancy. Some of these statements, even though the BERT model said this was most positive, the Azure model actually said this was negative. So the point I'm trying to make in here is there's a lot of discussion about how do we actually take this information and build out pipelines? So there is some amount of due diligence that needs to happen. So you want to be able to follow the process, and typically the process would involve, okay, I'm going to crawl the data, I'm going to process the data, I'm going to, call various sentiment analysis engines and then understand what's actually happening. But once you compare, you want to be able to have the right kinds of mechanisms set up so that you can appropriately, figure out whether this actually works for your particular scenario and build the right kinds of tooling in order to make sure that you are applying the right kinds of technologies for the right kinds of jobs. Okay, so that was kind of a quick demo. I know we are close to finish. I'm going to, just finish my remarks and then we can take a few questions. So what does it mean? It means that you got to prepare, because there's no solution which is going to solve your problems if you don't understand them well. And that's where I'm going to leave the slide where, in the past as a quant, when I was training to be a quant, I basically had to go through a lot of processes, understanding factor models, understanding optimization, understanding derivative pricing, understanding trading strategies, simulation, distribution fitting, stochastic models, et cetera, et cetera. And then we'd say, okay, for this particular data set, I'm going to apply these skills. Similarly, in today's day and age, you have so many technologies which are out there: real-time analytics, robotic process automation, natural language processing, deep learning, computer vision, chatbots, et cetera, et cetera. But you got to be able to understand what these technologies actually mean, and then how do you apply the right kinds of technologies for the right kinds of jobs. And there is not going to be a clear demarcation wherein we would say, this problem needs to go to the quant team, this problem needs to go to the data science team. The 21st century quant will integrate the learnings from traditional statistical modeling, traditional quantitative modeling, and apply the nuances and the innovations from the data science and the machine learning world, and then bridge them so that you can build the best possible models. So there is a lot of opportunity out there, but you got to make sure that you prepare to ensure that you are kind of understanding what's actually happening before you can kind of, apply them to your professions. So a couple of things I would do to prepare. You want to be able to engage in, AI ML communities. There's a lot of research happening, a lot of conferences happening. With COVID, a lot of these conferences have become online. So please tap into those opportunities so that you can get engaged with what's actually happening in the research communities. Continuing learning, I'm a big proponent of it. You have the programs like the Kaya, the CFA Institute has a bunch of programs, and I'm actually teaching some of those programs for the CFA Institute. Premier is another organization if you're focused on risk. We have a whole AI certificate program primarily focused on risk offered through Premier. And obviously, we offer a lot of companies programming and various aspects to help you understand the various facets. But finally, I want to say many of these concepts are not going to be usable if you don't know how to practice them. So you got to either practice them on your own or work with people who know how to code them up. You should be able to bring in the knowledge and apply them and test it out, ask the intelligent questions to make sure that you're battle testing these strategies appropriately before you deploy them. So there's a lot of things you could be doing. So please roll up your sleeves and try things out so that you know what you don't know, and then you can work with the right kinds of people so that you can get the best out of those collaborations. So that's all I had for prepared remarks. I'll stop here and I'll take any questions.
Thanks, Sri. And we see that some hedge funds are using this relatively successfully, and that the return on hedge funds that are implementing AI and machine learning substantially higher than what we see in other hedge funds. So do you think there's a lot of promise here, or do you think that there's some buzzwords and some exaggeration and some hype that's not necessarily warranted? So how do you separate the fact from the fiction of the AI and machine learning?
Yeah, that's a great question. And again, everything is not completely transparent, so we won't know how much of it is fact and how much of it is fiction. But what we are seeing is, if you just look at the profiles of the people companies are hiring, that's why I put up the JP Morgan and other companies hiring AI and machine learning teams. So there has been a significant investment in research within various organizations. They are actually investing in building data science teams. They're investing in researchers collaborating with Carnegie Mellon and many other universities to bring in the researchers and creating opportunities so that you can actually leverage the data sets they have. Now, that doesn't mean that machine learning, that's the attribution problem, right? So was it machine learning which actually led them to gain the extra alpha edge, or was it a comprehensive set of traditional technologies plus machine learning? So the short answer is, no one can just say we are going to ignore machine learning and data science. You've got to be able to have a strategy to leverage alternative data sets. You got to have a strategy to at least try out things to figure out whether you can get an edge by applying machine learning and data science within your organization. Now, what's going to happen if you use it? Well, that's again depending on your portfolios, where you're focused on, how much data you had, what amount of knowledge you were able to infer from that. So that's all based on the amount of testing and what has actually happened for that particular time frame. But the thought is, you will not be able to just say, I'm going to only focus on traditional factors and traditional things just because the world is moving so fast.
Now, do AI and machine learning models necessarily have to be a black box? Is there some way to understand and interpret these, or do we just have to trust what the models are doing?
I'm working with many financial professionals, and we are kind of actually coming up with the risk management framework for AI and machine learning models, which we'll publicize that in the next few months. And the thought process is, no one should be using black box models, especially for critical decisions. I think the science and the technologies and the interpretability research has progressed significantly enough that you should be able to go under the hood to understand what the models are actually doing. We don't need to explain every particular decision, but we need to be able to understand what's actually happening under the hood. So what that means is the black box is actually becoming a gray box. It's becoming more and more transparent as we speak. So a lot of companies are now making decisions saying, you know what, I'm not going to use something I don't understand. So we will, from the ground up, incorporate into our design features that these aspects need to be explained. These are the only kinds of models we are going to use as we build out our models. We need to be able to understand these aspects of the data processing, these aspects of the models. But we will also, depending on the use case, have situations wherein, a black box may give the best possible answer, and we don't care if we don't understand the underlying situation, and we may be able to use a black box. For example, if it's a marketing scenario, the best possible transparent model I have may not give me the best possible results compared to another model, which is getting us much better results. So we should be able to use it in case that's the scenario, and we are able to take that amount of risk. But if it's a high critical application wherein if something bad happens, it's going to have reputation risk, it could have significant amount of financial risk, you need to be able to design for interpretability and explainability and not just have a focus on the end results.
Yeah, and people tend to get excited about natural language processing. There's so many things you could do that's really different than what we've ever been able to do before. And a lot of people are talking about the earnings reports. We talked to Alexandria Technology a few weeks ago about this. Is NLP based on a written transcript of the earnings call, or can you actually do it in speech recognition and pick up maybe some emotions beyond the words they're saying?
That's a great question. There's a lot of discussion happening on, can we infer based on people's voices? My take is, I think it's very hard to generalize, especially with people with different accents. I grew up in India, so I have an accent. And, when I listen to some of my European colleagues speak, I kind of, sense that they may not be expressing the same amount of, emotions I'm expressing. versus somebody else from a different country expressing. So emotions may be very hard to interpret just by voice. So you may be able to, I mean, like, when I speak to some of my, colleagues, they say, I always like to have my Zoom meetings with the cameras on, just because I want to be able to like see you in the eye when I'm talking, when I'm having these kinds of discussions. And again, it's a personal thing. So if somebody wants to look at emotions, but I'm not a big fan of just in the context of trying to infer too many things. And the challenge is you don't have ground truth to validate against. And you may not be able to like really say that, okay, with 90% accuracy, I'm going to say that was a very negative statement, kind of a thing. So voice maybe for speech to text, awesome. So it gets you, instead of waiting for the transcript, you're able to do things in real time. You're able to gather keywords. You're able to like look for information. All that is good, but I'm not a big fan of trying to read too much into the actual emotions part.
Now, when you showed the graphs at the beginning, it looked like there were inflection points in the use of AI machine learning around 2012 and then maybe 2017. And now we're 5 years beyond that. Do you think we've done most of what we're going to do, or we're just getting started? So what do the next 5 years look like? Is it going to be linear from here, or is there another step function higher?
I wish I had the crystal ball, but I think there has been enough success points in the last 10 years for companies to put in significant amount of resources, and companies are investing heavily in AI and machine learning. So we will definitely see a lot of traction just because a lot of researchers have focused their research on AI and machine learning. There have been national strategies. There's been a lot of funding coming from governments trying to make sure AI and machine learning is adopted responsibly. There's been some amount of regulatory aspects about how do we make sure that we incorporate them more and more responsibly. And also in terms of innovations, I think the speed of machines have been constantly changing. There's been a lot of software frameworks which have constantly being upgraded to do new and better things. Every time there is a conference, we see newer models and newer innovations happening. So I think we're just scratching the surface at this point. So I think, I don't know whether it's going to be another inflection point per se, or kind of a linear trend with a different slope. But I think we have now uncovered that it's no longer just a theoretical aspect to it. And now we are seeing a lot of practical applications. So I think the usage and the growth will just grow from here on.
Now, if somebody's just getting started, do you have one favorite book that's maybe less technical and one favorite book that's maybe more technical for someone who's just getting started?
Yeah, I don't have one favorite book. I wish there was one favorite book. But I would say, there are so many online resources like company blogs, which basically have a lot of specific contextual information you could potentially read through. In fact, there is the NIST, which is the National Institute of Standards and Technology. They have basically formed multiple consortiums, and they have done significant amount of research on various topics. And they just recently issued a white paper on AI risk management. So wherein they cover a lot of themes on the positives and the negatives of AI and machine learning. And that was a comprehensive effort, bringing in a lot of industry practitioners and researchers. So I think that's probably a good place to start. And in the context of actual machine learning itself, there are a bunch of resources. Even if you just go to google.com and they look at some of their machine learning videos, you actually have code and examples and things you could potentially try and adopt various models. So you should be able to get going. And again, writing styles differ. Some people may like more examples. Some people may like more concepts. In my classes, I don't use a specific textbook, because the moment I adopt a textbook, after a month, I regret, because there's another book which has much better content, and I can't ask my students to buy 2 textbooks at that point.
Yeah, for the October exam at FDP, we're adding John Hall's book, Machine Learning for Business. The last question for today, Shri, and there's been a great conversation, but our time and our questions are ending at about the same time, which is good. So I work as an expert witness sometimes, and I work with attorneys, and they'll get in discovery 500,000 emails, right? And it's up to the computer to discover which 10% of those emails might be most relevant and less relevant. So if you were an attorney today and you're looking at that, 260,000 attorney hours or paralegal hours, kind of boiling down to a few seconds of AI and machine learning time, where does that leave the attorney? And does the attorney need some of those data skills to understand what's going on there?
Yeah, I mean, like it's kind of the same problem for doctors, right? So I mean, like, doctors can, if I get like an appointment after waiting for 3 months and I see my doctor, and my doctor has 30 minutes and he's already running late. So basically I have like 25 minutes with my doctor. And there's so many bits of information I want to share with my doctor, and my doctor doesn't have the time to listen to me. They want to get to a decision, move on, and it's just the information paralysis because they're bombarded with so much information. The same thing's happening with lawyers because there's the information bombardment, and they are only able to take strategic decisions with the amount of time they have. So I think the way to look at it is with summarization, with question answering systems, with some kind of ranking, with the ability to focus on specific keywords. I think what we are bringing is, AI and machine learning is guiding lawyers to look at the right places, and they will be able to strategically use their time to more thinking, to act more thoughtfully, to process the various, the mosaic theory, right? To connect the dots and focus on the right kinds of tiles, rather than just looking at this blob of information and figuring out how do we process each one of them. Obviously, there's going to be regret that, if it was all billable hours, they would be making a ton of money. But I think the way to look at it is like the clients will also have like fixed budgets. They would say, I want to be able to process all this information. So I think they're going to get an edge by being able to discretize and distill information to whatever they want to be able to do. I think that's where the industry is progressing, where in all fields, medicine, lawyers, consulting, applications in the engineering field, because we are going to be dealing with this information overload in all fields. The question is, how do we make sure that we distill the information enough so that we can focus on the right piece of information?
This has been great, Shri. We certainly appreciate you. And on that last point, what we're seeing is that human intelligence and artificial intelligence, they don't necessarily compete with each other. They could actually complement each other. And so a radiologist might see that AI does slightly better than they do. But if the radiologist is using AI, that combination is going to outperform either of them individually. And so to the extent that we use the tools to enhance our own subject matter expertise, that might leave us in a better place. So thanks for joining us today, Shri. And we look forward to everyone at our next webinar.
Yeah, thank you so much, Keith. Thank you. It was an absolute pleasure.